Right, so I have a decent experience working with Python for the past 5 years. I've worked on lots of modules for my different employers. I've done lots of personal projects using Python, but I have never uploaded any module into pip. So this weekend we are going to learn how to create a module or create a package and then uploading it into pip. So the success of this video will be if we can be able to install our package that we have uploaded into pip. So after going through this and 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 this, I found out that this is the my best fit documentation that you can use to create quickly a package that you can upload to pip, which is not so much dirty. You'll find this link in the description that you can follow. So I've created an empty folder here that we'll use to do our work. I'm going to use VS Code for this. So basically, to create a Python package, you need several files. You need a file called, so you'll need your own file, and it will be inside a folder called source. So I'm going to have my source folder here, and then inside my source folder, I'm going to have another folder, and I'm going to call it, since last week we did geodistance, I'm going to call it Dalmas geodistance, and inside this folder is where we are going to have the following files. You'll need an init file. So an init file, an init.py file is used by Python to indicate that this folder here is a module. Then I will need my own file. I'm going to call it, let me call it geo.py, and now geo.py will contain our code. Apart from this, geo.py should be inside the source. Move. Apart from this, you will need other files. You'll need tests. So I'm going to create a folder here for tests. So here is where you write you create your test scripts to test whatever you are doing inside here. We are not going to do tests in this video because it is out of scope. Then we are going to have licenses. So in this folder here, I'm going to add a file called licenses. So licenses, is a file that helps you tell people who are going to use your package how to use it, and what's the scope of their usage. Is it free to use, free to share, or you want them to tell people that they are using this package from you? It depends. So here there will be licenses, and then we are going to have a readme. You tell them how to use the package. So readme .md, it's a markdown file. Then we need a setup.config, setup.config file. So the setup.config file is a configuration file for the setup tools. It tells the setup tools about your package, the name and the version of the package, and it also helps with to include the code files or the files that are not supposed to be included into your package. So you put most of the configuration into the setup.py file. Then we need a file called pyproject.toml. So the pyproject file tells build tools what is required to build your project. Yeah, so I think we are complete. So let's start one by one. Let's first of all code our package that we'll be using.
deserve this, I just wanna break these chains. Always destined for greatness, true to myself, I never fake it. Seen too many ones that are so they get famous. And when I say the truth, most really can't take it. In spite of everything I've been through, I'ma make it. Fake friends, but on my downfall is toxic. Day one, started to outlaws for profit. Now all I do is write verses, no talking. All I do is put the work in, no option. This was everything I ever wanted. Created a legacy off of me, just being honest. And the fake ones hate, but it's all to no avail. They wanna see me lose, but you know I never fail.
So I guess by now you are knowing what this what this package is going to do. The package is going to calculate the distance between 2 points on a sphere, and the sphere currently we're talking about is Earth, and we want to calculate the distance between 2 places on Earth. So this is the constructor, and then this is the Reaper function that will print whenever you print the class, and then this is our function that calculates the distance. The calculation here is based on Haversine function. So Haversine formula is a very accurate way of computing distances between 2 points on a surface of a sphere using latitude or using the latitude and longitude of the 2 points. And here is a visual representation of that, and then this is the formula. This is a simple formula, but this is the final formula, and this is what I have coded here as Haversine. So the package majorly is going to calculate distances from 2 points. I know already there is a package that is created called Haversine, but for us our geo package is going to calculate distance from 2 points, but it will be calculating for either list of points or a data frame of points. So we need another function that will help us to do that. And let's continue coding. I think now we have a better context of what's going on.
I ain't gonna wait, that's all fact. Give me one shot and I'll never get the throne back. I'm sick of being cautious, I'ma go cause something, can't stop this. I'ma steal everybody's lane, call it shoplift. Sick of hearing everyone complain when they thoughtless. Taste the pain, it's like candy canes. It makes me go change into a better frame, into a better name. Society's insane, we all live for fame. Yeah. Cash in the bag, stadium packed. Born a rock star in this life, gonna live it up on the attack. Baby, I'm bad, I just wanna get caught up in this life. I'm crazy, I'm mad, do it no cap. Only God wants you, better go live it up. Cash in the bag, stadium packed. Baby, I'm bad, baby, I'm bad.
So here, I don't know if this is clear. Let me make it bigger. Make this bigger for you. I hope it was clear all along. That's my hope. So evaluate takes in data frame, takes in a variable for latitude column, takes in a variable for longitude column, and a measure. We are going to work with either kilometer or miles. This is what will be returned, like values in kilometers or values in miles. Then we are going to check if what we have put here is a data frame. If it is a data frame, then we also check that someone has provided the naming of the columns, so that we can only pick that data from the data frame, and we convert it into the list of tuples into a points list. But if it is not a data frame, if someone provides a data frame and does not provide the columns, then we raise an exception. If someone provides a list instead of a data frame, so we check if it is a list, we confirm that it is a list of points that have tuples that have more than two values or more, and then from there we convert it, we put it into points list. If not, if they just provide a list of values of scalars, then it will raise an exception. Yeah, so now we are going to compute distances for each of those values using this function that we created up here. And let's code.
chip on my shoulder cause they treat me like an outcast. I ain't gonna take that, stay back, I'll be swinging on till the hits coming all caps. I ain't gonna lay back, pray that someone's gonna help me, ain't nobody like that. I ain't gonna wait, that's all fact, give me one shot and I'll never get the throne back. I'm sick of being cautious, I'ma go cause something, can't stop this. I'ma steal everybody's lane, call it shoplift. Sick of hearing everyone complain when they thoughtless. Taste the pain, it's like candy canes. It makes me go change into a better frame, into a better name. Society's insane, we all live for fame, yeah. Born a rock star in this life, don't live it up on the top. Baby, I'm bad, I just wanna take care of me. Baby, I'm bad, no cap. Don't want some, better go live it up, cash in the bag. Baby, I'm bad, baby, I'm bad, baby, I'm bad.
And boom, we are done with our module or our package. I don't know why I keep on saying module. Yeah, so I think we need to log something here. I wrote some logging somewhere. I need to log this. Yep. Then this is not well aligned. Yeah. And then we need to log something else here. Okay, so what this evaluate function does, it takes in data frame, checks if the data frame is takes in a variable in df, checks it if it is a data frame, makes it a list of tuples. If it is a list, it makes it a list of tuples. If it is none of the two, it returns the error. It also checks if it is a data frame, and if it's a data frame, we have to get the names of the columns. Takes in a measure as an argument. Then from there we calculate distances. If someone gave the measure as kilometer, we return distances in kilometers. If the person gives the measure as miles, then we return distances as miles. So this is a constant that we use to convert kilometers to miles. If not, we raise an exception if they don't provide us kilometers and miles. So our package is ready, and it is ready to be shipped to PIP. I think I have not tested anything, but the major goal is to have a ship. So we need to get a license. I have a licensing text here, so anyone can use it. Is MIT license. Then our project.toml, I'm going to get from the same documentation. I have it on my side here, so I'm going to just use it, copy it and put it there. Where is it? Remember, this document is the one that will provide us with dependencies to build our project. So here the dependencies are setup tools, pandas, and wheel. Remember, we have used pandas here. Where is it? Let me close this. We have used pandas here. Yeah, so that's why we are putting it in project.toml. Then in readme I have my text I wrote somewhere. For readme it is not so long. Yeah, then so we have this, then we have the setup.config. The setup.config, so this is the setup config. The package is called dalmasgeo. It's version 0.1. This is the author, this is the email, the description of the package. The long description is the readme.md. This is the long description. You can continue writing blah blah blah. This is where you can find it. I've already pushed the code to Git and so forth. I doubt if there is any other file that is required that we have not given. So we have this as our package. So if we look at what we have done so far, this is where we are. Now what is remaining is to build the package. To build the package, we need to come down here and see how to build this package. So I have to have an environment. Yeah, so let's check. I hope this is big enough for you to see. Okay. Yeah. I use PyEnv for my Python versions, so PyEnv versions. So I have several versions. I'm using that one set by the system. That's fine. So Python -m venv. So we're just creating an environment. Then from there, I was working on another environment. Deactivate. So what do we have here? So source venv bin activate. Then we are going to have this Python that installed -m build. Yeah, so we have successfully built this. So we can see them we have seen a distribution directory. We can try to check it out in VS Code. Yeah, so we have this. We have these two files that are created after building. So what's remaining is pushing this to the index, the pip, and basing on this documentation, you have to create an account in test.py or pyp or whatever. Here, so you have to create an account here. You register. So for me, I've already registered. You can come and register here. So it is a test environment you can use to test your code before you put into the real pip environment. So what we are going to do is to upload those packages, that package that we have created into pip, and to upload it we are going to do this Python 3. So we need to install Twine first. So I'm going to do pip install Python, right? It was Python that. So I'm not doing Python 3 because each folder of mine I'm using PyEnv to localize Python versions, several different Python versions using PyEnv. Then I'm going to upload. So this is the code that uploads it to the test. So Python that. So the username is Daddy Codes, the password and yeah, so the package is here. We can see it. We can use this code to install it. So what I'm going to do is here where we are, I'm going to deactivate that environment just to be sure, and then I'm going to create another environment, python -m venv. I'm going to call it not test environment, I'm going to call it geo environment, right? Then activate this. Then after activating that, I'm going to install the package because we want to test and see if it is working, and I want to test it in Jupyter Lab. So we test it in IPython. Now let's test it in Jupyter Lab so that we can work with the dataset. Install Jupyter Lab.
I've got an itch I can't scratch, I'm missing a piece that completes a whole part of me, an open wound scar to see. Everybody come here, gather round, welcome to the freak show, the best in town. What the hell's wrong with me? I don't get along with anybody, honestly. I've been living in my own head constantly, thoughts jumbled around, think I need a new lobotomy. Wait, all these thoughts are too negative. I don't wanna get lost in the sedative. Gotta show them what I got, I'm competitive. You know I'm about to go off, I won't let them win, I'll take a stab. I wanna chase a bag, I wanna weigh, I can change all the things I lack. I gotta face the facts, I got a taste in that. Got me obsessed with the rest, I got an itch to scratch.
So let's launch our Jupyter Lab. We want to launch it here. Alright, so we are going to test our package that we have created. So this is our package, and this package is inside Dalmas GeoDistance and is inside. So this is our source code, and remember, in our setup.config we specified that our package directory is here. So this is the main that we are going to use to when we're importing. I'm going to show you. Remember that it requires Python 3.10, which is at this moment Python 3.6 is more stable, but since this is our package, we can use any. So for now, let's import. So from Dalmas GeoDistance, remember Dalmas GeoDistance is this inside source. We are going to import this file. So from that .geo import. So import. In fact, what we do, let's do from Dalmas import geo, so that it imports the whole file. Then we are going to import pandas. Let's also import pandas speedy. Then our data is here, world cities. So it is going to be pd.read CSV, and the CSV is world cities. We can try to look at that data. So that data is huge. I don't like these errors. So here is low memory equals to false. We can try to look at that data's head. Then let's give our origin the point at which we are going to be measuring distances for several places. So remember, at this place we are going to measure distance from somewhere to this place, and then distance from somewhere to this place. So our origin, we can just guess 32 by 78. Then we're going to create an object. So let me just call it geo object, and geo object is going to be our geo dot. So our geo here, geo is having this geo, so geo dot geo, and that geo takes in origin as the parameter. So here's the origin. Then after that we are going to calculate the distances. So we are going to do the function for calculating distances for every one. So remember, this one calculates the distance for just one destination, and then this one calculates distances for a data frame of destinations or a list of destinations. So we're going to use evaluate instead of using distance. So we're going to do this object that we have created dot evaluate, and we're going to evaluate data. If we pass data without passing anything, remember data is a data frame, it's going to throw this exception that you need to provide column names, because we have not provided column names. And here we stated that we have to provide, if these column names don't exist, then it raises an exception. So we have to provide the lat column and the long column, and here we're going to have this lat column is going to be equal to something, and then this long column is going to be equal to something. So our lat column is the latitude, and then our and then our long column is the longitude. So let's try calculating this and we see if it works. Yeah, so it works. It returns to us the distances, and these distances are in kilometers because we have not passed anything, and it has a warning here. It tells us that returning distances in kilometers. Remember, we had placed that warning somewhere here that it should warn them that anyway it is returning it to distances, so people know that it is in distances, in kilometers. But if we want it in miles, then we have to pass measure as miles. So supposing we wanted it as miles, we'll put here measure equals to miles and run it. Yeah, and we have it returned here. If you want to result, if you want to see what is returned, let me break this code, it's not long. You can put it there. It will still give us that. It will give us that warning. Then the result is a list of distances. Yeah, so we have seen how we can create a package and uploading it to pip. Though we have uploaded it to pip test environment, but it is the same way. You can continue following that document and see how to upload it to pip live environment, provided your test works. Yeah, so this is what I have for you this week, and bye.
Baby, I'm bad. I just wanna get caught up in this life. I'm crazy, I'm mad. Do it no cap. Only got one.